Imagine if the fastest way to travel across the universe wasn't by moving faster, but by making the distance itself disappear. Today we're going to explore warp drives, space-time, and why folding or breaking space may be far more realistic and efficient than breaking the speed of light.
Hello, welcome back. As you probably already know, the universe has a speed limit. That limit is 299,792 kilometers per second, or 186,282 miles per second in freedom units, if you're on the US side. And the universe has been breaking its own speed limit ever since the Big Bang. Like ants on a balloon, we can walk around said balloon no faster than c, the speed of light. However, that balloon can inflate as fast as it wants to, and it does. In fact, the further away you look in space, the faster the universe is expanding, and it's taken us along for the ride. So when people ask me, do you think we'll ever be able to travel faster than light? My answer is always a resounding yes, as long as we play by the rules. It's currently impossible for anything with mass to travel faster than the aforementioned speed of light. But we don't want to travel distances. That's a bunch of work. We want to bring our destination to us. Please allow me to clarify. E equals mc squared. We know that. We've all heard it. But what does it actually mean? Essentially, mass and energy are two forms of the same thing. The equation tells us how much mass corresponds to a given amount of energy and how much energy is stored a given amount of mass. What they didn't tell us is that Einstein's work didn't stop with E equals mc squared. His theory of general relativity opened the door to an idea that sounds like science fiction: warp drives. Miguel Alcubierre Moya is a Mexican-born physicist who in 1994 proposed an idea that would later be called the Alcubierre warp drive, which consists of a ship sitting inside a region of flat space-time. The technology is to expand space behind it, stretching it out and pushing it forward, and closing the space-time in front of it, collapsing it, bringing it closer. This encloses the spaceship in a kind of warp bubble, so that it moves through space-time without breaking the speed of light. So, the ship isn't moving, but space around it is. So, here's the mind-blowing part. If an Alcubierre warp drive actually worked, the crew wouldn't be racing through space faster than light. They'd be sitting inside a bubble of normal space-time while space itself carried them to their destination. That means they might avoid extreme time dilation that comes with light speed travel. You see, when traveling at relativistic speeds or close to the speed of light, weird things start to happen. One of those is, from your perspective, nothing changes. The clocks tick normally, your vibe is chill, but not back on Earth. Time is just flying by as you cruise along near the speed of light. Back on Earth, time is just flying by. So much so that if you were to go from Earth to Jupiter, say 99% the speed of light, and come back, you would measure, we would measure on Earth 87 minutes, while you would measure about 12 minutes. Doesn't seem like that big of a difference until you start to get into bigger distances, galaxies and such. That becomes a lot more time passing by on Earth. To do this, we would need some form of exotic matter that we don't have yet. Something we do have plenty of, though, is gravity. We just don't know how to see it, collect it, or use it to our advantage yet, but it's there. Earth is currently riding that aforementioned wave of space-time already, and once we figure out how to see and control that energy, we'll unlock the universe. As I've said in previous videos and at the start of this one, I believe that the fastest and most efficient way of traveling in the future will involve barely any movement on our behalf at all, just the manipulation of space-time to be able to step across the distance and to get where you need to be. This already happens every day through quantum tunneling, and as I stated earlier, universal expansion. Sure, quantum tunneling and expansion of space-time are two totally different separate phenomena, but they both allow for faster than light travel, and both could be exploits into the very nature of space-time itself and how to manipulate it. I'll speak on it in another video, but if you're unaware, quantum tunneling is the effect that you get when you have two entangled particles that seem to share information instantly, which scientifically is faster than the speed of light. It's instant. In a nutshell, if you have one entangled particle here on Earth and observe what type of spin that particle has, and then you can instantly determine the spin of the entangled particle, no matter its place in the universe. Einstein called it spooky action at a distance, and indeed it is. What's the reason I'm telling you about all this, you may ask? It's the foundation for faster than light travel. It's already here. We just need to find it, to be able to study it, and ultimately be able to manipulate it. Whether it's through space-time, through quantum tunneling, or through riding the wave of universal expansion, faster than light travel is the future. And if we all put our heads together, we just might be able to get to the other side of the event horizon together. Thanks for tuning in. If you liked what you saw, like and subscribe.